we've got these two different types of equations we just introduced, explicit and recursive. So explicit.
So is this on page 6?
Yes. Explicit versus recursive.
So we put these notes on page 6?
Yes. 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 Page 6. Okay. I'm going to write both of these out. I'm going to leave a little bit of space. Our explicit equation versus our recursive equation. So our recursive equation, that was the one that was kind of the newer one. What is the recursive equation based off of again?
The one before.
The figure right before, right? So that's how recursive pieces together. Recursive is going to be based off of whatever comes immediately before. So it's based off of the previous figure. So our recursive, in order to get the answer, we had to know what the previous figure was, and then we just added on to that. Our explicit, what was connecting the explicit equation together? What was it based off of?
Time.
The time, yeah. So sometimes that might be the time, or in a different pattern, maybe it might be the figure number. So rather than being based off of what comes right before, explicit is based off of whatever position it is in the sequence. So is it the third thing? Is it the 50th thing? Is it the 5041st thing? So recursive is always based off of what comes immediately before versus explicit, which is based off of the position anywhere in the sequence. So just to get an example written down, our explicit equation from problem 1.2, so f of t was 4t plus 1, and that's what I think pretty much all of you guys had written down on your paper. Just as a reminder. So when a lot of people think of an equation, what they're actually thinking of is an explicit equation. That's what most people have experience with, is explicit equations. A lot of people are used to thinking visually or informally about a recursive equation, but we need our function notation and some things we've been learning about that in order to actually write the equation for that. There actually is one more piece of the recursive equation. Recursive bases off of what happened in the previous figure, which is based off the figure before that, which is based off the figure before that, which is based off the figure before that, all the way back to the beginning of the sequence, right? So there's this kind of anchor point at the beginning of the sequence that lets you figure out all those previous figures. So usually if you're going to have a recursive equation, you need to give some information about that first figure, because that first figure really is going to determine everything that comes after it if you're thinking recursively. I use this to get the one right after that, and then I use that to get the one right after that, and so on. So we can express that in function notation. If you think about our growing dots problem, at the beginning was a time of what? Well, I'm going to cover this up for a minute so I can put this up here. Here's our pattern. So this says at the beginning. What time do you think at the beginning is? 0. So if I'm going to have a recursive equation, I need to define what I'm starting with so that I know what each thing is based off of. So this is the starting thing, which determines this, so that this can determine this, and so on down the line. I can express that in function notation. So if I put in a 0, basically at a time of 0, what am I starting with? Yeah. And then from there, to get any figure in the series, I can do the figure before that, which you guys said I could do as t minus 1, right? And add 4 to it. These things all together represent a recursive equation. It looks a little bit longer, and again, that's because if I'm going to keep basing things off of what comes right before it, I have to have information about where I'm starting. Because I have to have some sort of anchor point that everything's based off of, growing from. I'm gonna label a couple of things on here that you can label too in your notes just to remember, so that you remember what key pieces are going on here. So this first part, that's basically information about the start of the sequence, right? You have to tell where it starts. So this would be the starting value of the sequence. You should include that in a recursive equation. And then this part, just to remind you, that was our notation for the previous figure, right? So whatever time we're at, we're going to look 1 minute earlier. T minus 1 is 1 minute earlier. So if we want a time of 5 minutes, we would look at the figure from 4 minutes. So this is just the notation for our previous figure. That would be a good thing to label so that we remember that. And that's where the recursive comes into play, is that you've got that previous figure in your equation. And then we're going to add 4 to it each time, which is where the plus 4 comes from.